Scaling long-running autonomous coding. What happens when agents code for weeks? What if you could throw hundreds of coding agents at one project and let them run for weeks? Cursor has been experimenting with exactly that long-running autonomous coding agents, working continuously, coordinating changes, and producing massive code bases. In this video, we'll break down what they tried, what failed, what finally worked, and what they learned after pushing agents to write over 1 million lines of code. Today's coding agents are great at focused tasks, but give one agent a giant project, something that normally takes a human team months, and it slows down fast. So the obvious idea is run agents in parallel. But then you hit the real problem, coordination. Who works on what? How do you avoid duplicate effort? And how do you keep everyone moving toward the same goal? Cursor's first instinct was not to rigidly plan everything up front, because big projects are messy and the best path isn't clear at the start. Their first attempt was a flat team. Every agent had equal authority. They used a shared coordination file where agents would check what others were doing, claim a task, update their status. To stop two agents from grabbing the same task, they added locks. And it broke in fascinating ways. Agents would hold locks too long, forget to release them, or crash while holding them. Even when it worked, locking became a bottleneck. 20 agents would move at the speed of 2 or 3 because everyone was waiting. They switched to optimistic concurrency. Basically, that was more robust, but a deeper issue showed up. With no hierarchy, agents became risk-averse. They avoided hard problems, made tiny safe changes, and nobody owned end-to-end progress. Result? Tons of activity, but not enough forward momentum. So Cursor changed the structure completely. Separate roles. Planners explore the code base and continuously generate tasks. They can even spawn subplanners for specific areas. So planning itself becomes parallel. Workers do the opposite. They don't worry about the big picture at all. They grab a task and execute. No coordination overhead. Just finish the job and push changes. Then, at the end of a cycle, a judge decides whether the system should keep going, and the next iteration starts fresh, reducing tunnel vision and drift. This setup solved most of their scaling issues and kept the overall project moving. To stress test it, they aimed at a wildly ambitious goal, building a web browser from scratch. The agents ran for close to a week and produced over 1 million lines of code across around 1,000 files. They also tried a huge in-place migration, solid to React inside Cursor's codebase, running over 3 weeks. With hundreds of thousands of lines changed, it was passing CI and early checks. And one long-running agent rewrote video rendering in Rust, reportedly making it 25x faster, plus adding smooth zoom and pan effects with spring-like motion and blur. After deploying billions of tokens across these systems, Cursor says the result was more effective than they expected. But the big lessons were surprising. Model choice matters for long-running autonomy. They found GPT 5.2 models stayed focused, followed instructions better, and implemented more precisely over long periods. Different models shine in different roles. So they now pick models based on whether the agent is planning or working. Many improvements came from removing complexity, not adding it. Some roles they added, like an integrator, ended up creating bottlenecks. The sweet spot is middle structure. Too little structure causes chaos. Too much makes the system fragile. And the biggest lever? Prompting. The way agents are instructed shapes coordination, focus, and whether they spiral into unproductive patterns. Cursor's big takeaway. Yes, you actually can scale autonomous coding by adding more agents, and hundreds of agents can make real progress on a single code base for weeks. Coordination is still hard, and they're far from optimal, but the direction is a lot more promising than people assumed.